Alright, this is the Math 3 Unit 10 Worksheet 3. I'm going to work through some of these problems. 1 through 5, you're to identify one positive coterminal angle and one negative coterminal angle for each of the following. Coterminal means in the unit circle, or they're pointed in the same direction. So, for example, number 1, we got 0 degrees, 90 degrees in the positive direction, which is counterclockwise, 180, 270, 360. Just in setting this up, notice that 0 and 360 are pointed in the same exact direction. Obviously 0 is not equal to 360, so you have two different numbers, but they're pointed in the same exact direction. We call those coterminal. 100 degrees is going to be pointed a little past 90. But if we go around, picture that as a spinner. If we go around a full circle and point at 100 again, that's going to be coterminal. And a full circle has 360 degrees, so if I take 100, start there, and add 360 to that, I'm still going to be pointed in the same direction, and that gives me 460. So that's another positive coterminal angle with 100 degrees. I could spin the other way around too, so if I start by pointing at 100 and spin clockwise in the negative direction, a full circle, 360, I'm also pointed that way, so that would be 100 minus 360, which is going to give us negative 260. So negative 260 is also pointed in the same direction. So for all of these, that's the trick. You add 360 or subtract 360. Let's take a look at number 5 as well. So number 5, we're pointed at negative 400 degrees. So if I add 360 or subtract 360 to negative 400, I'm going to get another coterminal angle. We're pretty far negative though, so if I want to get, let's shoot for a positive coterminal angle. So I'm going to take that negative 400 and add positive 360 to that. So we're going around the circle in a full circle in the positive direction, and we end up with negative 40. Now that's another, so negative 40 and negative 400 are pointing in the same exact direction, and so negative 40 degrees is coterminal with negative 400. Well, let's start with negative 40 now. If I continue to go around another full circle in the positive direction, then I end up at negative 40 plus 360, which is 320 degrees. And so 320 is coterminal with negative 40, but negative 40 is coterminal with negative 400, so all three of them are coterminal with each other. 6 through 20, we're to sketch each angle in standard position, identify the quadrant in which the terminating ray lies, identify the reference angle, and identify the sine, cosine, and tangent ratio for each. So let's start with 7. So 240, let's locate that. So 0, 90, we're going in the positive direction, 180, 270. So 240 is pointed in the third quadrant. The reference angle is the acute angle from the terminal side always to the x-axis. and it forms this right triangle. And the difference between 240 and 180, positive difference, is going to be 60 degrees. And now we're looking for the sine of 240, cosine of 240, and the tangent of 240 degrees. So we're going to want to know the side lengths of, this is a 30, 60, 90 right triangle. One way to do this is to use make the side across from 30 a length of 1. The hypotenuse will be double that, so that'd be length of 2. And then the side opposite from 60 would be the square root of 3. And that, from the previous homework and lesson, we looked at that triangle. There are other 30, 60, 90 triangles that are similar to this that we could use other lengths. For example, we can make the hypotenuse 1. We just cut all these in half, make one 1/2 and the other root 3 over 2. I'm going to work with this. And then we need to respect the quadrant. So all x values are negative, so this is going to be a -1 because that's your x is your horizontal base. And then all y values in the third quadrant are negative as well, so root 3 is going to be negative. The hypotenuse we're going to leave positive. So, continuing on here, sine is opposite over hypotenuse. The opposite of 60 is negative root 3. And the hypotenuse is 2. For cosine, cosine is adjacent over hypotenuse. The adjacent to 60 is the -1 over 2. And tangent is opposite over adjacent. So negative root 3 over -1, which reduces to just positive root 3. Number 9, 150 degrees. Well, marking going counterclockwise, we got 0, 90, 180. So 150 is between 90 and 180, closer to 180. So there's my terminal side pointing to 150. We're in quadrant 2. Our reference angle is the angle from the terminal side to the x-axis always, and it's always an acute angle. And that angle is the difference between 180 and 150, which is 30 degrees. So we have a 30, 60, 90. The side length, with our 30, 60, 90, we always say, well, the side length across from 30, let's let that be 1, and the hypotenuse would be 2, and the side across from 60 would be root 3. And if we respect the quadrant, everything on the left side, x values are negative, y values are positive, hypotenuse we're always going to keep positive. So the sine of 150 is equal to opposite of, we're looking at the reference angle, so 30, opposite of 30 would be 1, over hypotenuse, 2. The cosine of 150 degrees is going to be the adjacent to our reference angle, which is negative root 3, over the hypotenuse, which is 2. And the tangent of 150 degrees would be the opposite, which is 1, over the adjacent, which is negative root 3. Here we can rationalize our denominator, multiply top and bottom by root 3, and we end up with root 3 over 3, and this is still negative. Number 11, 315 degrees. Well, if we start at 0, go counterclockwise, we got 90, 180, 270, and then back at 0 we're at 360, because 0 and 360 are coterminal. 315 is between 270 and 360. In quadrant 4. Our reference angle is the angle from our terminal side to our x-axis always, which is, and it's also needs to be an acute angle, and it's the difference between 360 and 315, and we get 45. So this is our 45, 45, 90 right triangle. The side lengths that we're going to use are 1, 1, and root 2. And then we're going to respect the quadrant. Our x value is positive 1, where our y value is negative 1. So our reference angle is 45 degrees. The sine of 315 degrees is opposite over hypotenuse, so negative 1 over root 2, which can simplify, multiply top and bottom by root 2, you end up with negative root 2 over 2. The cosine of 315 is positive 1 over root 2. Multiply top and bottom by root 2, and you end up with root 2 over 2. And the tangent of 315 degrees is opposite over adjacent, which is negative 1. Let's take a look at 15. 15 has a negative angle. In the negative direction, we still start at 0, but we're going clockwise. So this is negative 90, negative 180, negative 270, negative 360. So negative 300 is between negative 270 and negative 360. Probably close. It's actually closer to the 270, so let me resketch this. So negative 300 about right here, and we get this reference angle. So we're in quadrant 1 with a reference angle of 60 degrees, because that's the difference between 360 and 300. So opposite 30 we write 1, opposite the 90 we write 2, opposite 60 we write root 3. We're in quadrant 1, so our height and our base length, our x and y values, are both positive. So the sine of negative 300 is going to be the opposite of the reference angle over the hypotenuse, so root 3 over 2. The cosine of negative 300 degrees is the adjacent to the reference angle over the hypotenuse, so 1 over 2. And the tangent of negative 300 degrees is the opposite over the adjacent, so root 3 over 1, which is just root 3. Let's take a look at number 19. 690 degrees. That's more than 360, so we're going to have to go around more than once. So 0, 90, 180, 270, 360, add 90 to 360, we're going to be at 450. Keep adding 90, we're going to be at 340. Then add 90 again, we're going to be at 430. I'm sorry, I messed up here. Should not be 340. At 180, 180 is going to be coterminal with 540. And then 630. And then back to 720. So we see that 690 is between 630 and 720. And that's the difference between 690 and 720, which is 30 degrees. So we get a 30, 60, 90. Opposite is going to be 1, but we're going to make it negative 1 because it's below the x-axis. Root 3 and 2. And so we're in quadrant 4. Reference angle is 30 degrees. Sine of 690 is going to be opposite over hypotenuse, so negative 1 over 2. Cosine of 690 degrees is adjacent over hypotenuse, so root 3 over 2. And the tangent of 690 degrees is opposite over adjacent, so negative 1 over root 3, which if you multiply the top and the bottom by root 3, we can rationalize the denominator and get negative root 3 over 3. On 21 to 30, we're to sketch the angle in standard position and identify the sine, cosine, and tangent ratio for each. Here, it's important to recall that if we're a distance of 1 from the center, or if we're on the unit circle, then your x value is your cosine of theta, and your y value is your sine of theta. And your tangent of theta is always going to be y over x, which is sine over cosine. These are for x and y on the unit circle, which is a circle with a center at 0, 0 and a radius of 1. Okay, so with that in mind, if we go to 90 degrees, right, and if I draw in my unit circle, so this is a circle, center 0, 0, radius 1, and I look at the coordinate of that value at 90 degrees, my x value is going to be 0, my y value is going to be 1. And so the sine is your y value, so 1. Cosine is the x value, 0. Tangent is y over x, so 1 over 0. But we can't divide by 0, and so we say undefined. Let's take a look at number 23. 180 degrees, at 180 degrees, what would our coordinate be on the unit circle? The x value would be negative 1 and the y value would be 0. And so the sine of our angle, 180 degrees, is your y value, which is 0. And the cosine is the x value, which is negative 1. The tangent is the y value over the x value. 0 divided by negative 1 is 0. (25) 630 degrees. We can do what I did back in number 19, where you just keep going around the circle to find out where that is. Or another way to do this is just to find a smaller angle that's coterminal with it. And if you recall, we found coterminal angles by just subtracting 360. So if you find 630 minus 360, you get 270 degrees. So 270, so there's 0, 90, 180, 270. 270 is coterminal with 630, sorry. They're both at the same location. So here's our unit circle. We want the coordinate on the unit circle at that point. Well, we're only one below 0, 0, so that's at 0, negative 1, where 0 is your x value, negative 1 is your y value. Sine is the y value, cosine is the x value, tangent is y over x. But we can't divide by 0, so we write undefined. Number 31 to 40, we need to identify all the quadrants where the terminating ray for theta can lie so that the equation is true. Hint, there should be at least 2 quadrants identified for each of these. Hint number 2, do not attempt to actually solve for theta, just identify the quadrants where the reference angle will make the equation true. And hint number 3, sine squared theta is mathematical notation for sine of theta squared. So if we take a look at number 1, we notice that the sign is negative. And if we go back to what we were saying about the unit circle, where the x value on the unit circle is your cosine, the y value is the sine, the tangent's y over x. We can put those things together, and here's what we end up with. So we know that sine is y, so our y value is negative. So think in which quadrants is your y value negative? Well, your y-axis is the height, so anything below the x-axis, you get a negative y value. So in quadrants 3 and in quadrants 4. And that's all we need to do here. We're just identifying the quadrants. So your answer is quadrant 3 and quadrant 4. Number 33, we have the tangent is negative. Well, tangent, remember, is defined as y over x. So we have y over x is negative. Okay? In order for you to have if you divide two numbers and you get a negative answer, that means one of them has to be positive and one of them has to be negative. So we have two options here. We can have y as negative and x is positive. Okay, that's option number 1. And then option number 2 is that y is positive and x is negative. Okay, so now let's think where this would be. For option number 1, if y is negative and x is positive, what quadrant will we be in? Y is negative, that's below, x is positive, so that would be, option number 1 would be in quadrant 4. Option number 2, y is positive and, x is negative. If y is positive, x is negative, then we're in quadrant 2. And so that's our answer for 33, quadrant 2 and quadrant 4. take a look at number 38. 38, we have that the cosine is plus or minus 3 over 5. Well, cosine is your x value, and it's saying x could be positive or negative. Well, where x is positive on the right-hand side, so that would be quadrant 1 or quadrant 4. But x is negative on the left-hand side, so that would be quadrant 2 or quadrant 3. So we're okay with any of those because our cosine could be positive or negative. So we want to say quadrant 1, 2, 3, and 4.